Hey guys, me again. Parent-teacher conferences just ended, and it's about 9:05 on a Thursday night, so I'm a little bit tired, but I think I'm still coherent enough to tell you about exothermic versus endothermic reactions, and it's very important that you listen carefully. So, exothermic reactions, as you remember, release energy. Endothermic reactions are the opposite. They gain energy. So when the reaction takes place in an exothermic reaction, energy is a product of the reaction. We have heat, we have light, sound, lots of things like that. Now, in an endothermic reaction, energy is taken up. So light is absorbed, or heat is absorbed during an endothermic reaction. Every reaction, dropping things. Every reaction has reactants on one side and products on the other. On the test, I noticed that several people missed this question. Reactions are the stuff that gets combined or starts out before the reaction takes place. Those are reactants. After the reaction has taken place, the products are the thing that is formed from the reaction. Now check this out. If there's more energy on this side, on the reactant side, than on the other side, it's endothermic. If there's more energy as a product, it's exothermic. So endothermic versus exothermic depends on which has more energy. Is more energy being taken at the beginning in order to get the product, or is more energy being given off at the end in order to get the product? Okay? We can look at it another way also. So here's an exothermic reaction, and you can see in the exothermic reaction you have chemical energy on this side. Remember, chemical energy is that energy that's stored in bonds. So you have chemical energy on this side being stored in the bonds, and as the reaction takes place, the products have a lower level of chemical energy than the reactants. You can think of a hot pack. So when you have a hot pack, you need to break it or shake it up. So you need to add energy to it. That's the starting energy here that you see. So you're adding energy to the system, and then because it's a hot pack and you just hurt your leg and you want to make your cramps go away or whatever you're using it for, energy is released in the form of heat. And the product's chemical energy is less than the chemical energy of the reactants was. It's exothermic. The products, in the bonds of the products, there's less chemical energy stored than there was in the bonds of the reactants. Now let's contrast that to an endothermic reaction. An endothermic reaction, we have the same chart. So we have the chemical energy that's stored in the bonds. This is another test question. Lots of people missed it. So chemical energy is energy stored in bonds. Don't miss it this time, okay guys? You can see the reactants have less energy stored in their bonds. Now we still have that activation energy. If you think of a cold pack, this is a good example of an endothermic reaction. So for the cold pack, you still have to put energy in, and you have to shake it to get the cold pack started. And as soon as you shake it and you put that initial energy in, the cold pack continues to take energy from the environment. Now it's taking heat out of the environment. It feels cold against your skin, and so your ankle feels better when you've heard it in sports. Alright, so you have this cold pack, it's absorbing energy as it's taking place, and the products now have more energy stored in their bonds. So in the bonds of the products that have been made, when your atoms were rearranged, there's more energy stored than there were in the bonds of your reactants. Okay, here's some more examples. So examples of an exothermic reaction. A candle flame. Mixing sodium sulfate and bleach, rusting iron, burning sugar, mixing water with a strong acid, mixing water with an anhydrous salt, crystallizing a liquid salt, nuclear fission. This happens on the sun, releases a lot of heat, that's why we're here today, and also mixing water and calcium chloride. I want you to think back to the nuclear fission. So the sun is producing this exothermic reaction, nuclear fission. It's releasing heat and light. And then plants are absorbing that light every day. Now plants, when they absorb that light, they produce sugar by photosynthesis. That's endothermic. Exothermic, the sun releasing the heat. Endothermic, the plant absorbing the heat. Baking bread is an endothermic reaction because you're putting heat into the reactants and you're getting out the product of cooked bread. Endothermic, it's absorbing the heat. Boiling an egg, you're putting heat into the egg is absorbing the heat, and that chemical reaction is taking place. It's endothermic. The egg isn't giving off heat, the egg is taking in heat. Splitting a gas molecule, mixing hot water, making an anhydrous salt from a hydrate, melting solid salts. The reaction of barium hydroxide octahydrate crystals with dry ammonium chloride. Finally, the ones that I really want you to remember and store in your brain, a hot pack is an example of an exothermic reaction because it puts out heat, and a cold pack is an example of an endothermic reaction because it takes in heat from its surroundings. I hope that clears up things for you, and I hope that you can memorize this for the next test because I don't want anybody to be lost when it comes to exothermic and endothermic reactions.